Looking up at the night sky, you see stars scattered like diamonds across black velvet. You see the familiar constellations your ancestors mapped, the same moon that has watched over humanity for millennia, the same cosmic dance that has played out for billions of years. But what if I told you that everything you think you know about the universe, every assumption, every certainty, every foundation of cosmic understanding is built on a lie? The Big Bang did not bang. There was no explosion, no sudden eruption of matter and energy from a singular point. There was no moment when everything began, no cosmic starting gun that fired the universe into existence. The very name we've given to the origin of everything is a mockery of what actually happened, a simplified fairy tale we tell ourselves because the truth is too vast, too alien, too fundamentally disturbing for our minds to process. You've been told that 13.8 billion years ago, the universe emerged from a state of infinite density and temperature, a singularity so compressed that space and time themselves had no meaning. You've been told that in a fraction of a second, this primordial seed expanded faster than the speed of light, cooling and stretching until it became the cosmos we inhabit today. You've been told this story so many times, with such scientific authority, that you've never questioned its most basic assumptions. But the James Webb Space Telescope has seen something that shouldn't exist, something that breaks every rule, violates every theory, and turns our understanding of cosmic history inside out. In the deepest images ever captured by human technology, in photographs that peer further back in time than any eye has ever seen, Webb has discovered galaxies that are impossible. Massive, fully formed spiral galaxies existing just 600 million years after the supposed Big Bang. Cosmic structures so mature, so complex, so impossibly organized that they couldn't have formed in the time available to them.
Imagine you're an archaeologist digging through layers of ancient Earth, expecting to find primitive stone tools in the deepest strata. Instead, you uncover a perfectly preserved smartphone, its screen still glowing with messages from a civilization that shouldn't have existed for millions of years. That's exactly what Webb has done to cosmology. It has found the impossible, photographed the paradoxical, and delivered evidence that our most fundamental assumptions about the universe might be catastrophically wrong. These aren't just slightly older galaxies than we expected. These aren't minor adjustments to our timeline. These are cosmic impossibles, galaxies that contain hundreds of billions of mature stars, supermassive black holes that dwarf anything we see in the modern universe, and chemical compositions that suggest stellar evolution spanning billions of years. All of this existing in what should be the universe's cosmic infancy, when the first stars were supposedly just beginning to flicker into existence. The implications are staggering. If these observations are correct, and multiple independent confirmations suggest they are, then either our understanding of galaxy formation is fundamentally flawed, or time itself doesn't work the way we think it does. Perhaps the universe is far older than we've calculated. Perhaps the Big Bang Theory is an elaborate fiction. Perhaps we're living in a cosmos that operates by rules we haven't even begun to comprehend. Consider the absurdity of what we're seeing. According to standard cosmological models, the early universe was a hot, dense soup of particles that took hundreds of millions of years to cool enough for the first atoms to form. These atoms then had to clump together under gravity's patient pull, forming the first stars in a process that should have taken hundreds of millions of years more. Those stars then had to live out their entire life cycles, die in spectacular supernovae, and seed the universe with heavy elements before second-generation stars could form. Only then could the complex chemistry necessary for planet formation and life begin. This process, from the first atoms to the first complex galaxies, should have taken at least 1 billion years, probably longer. Yet Webb is showing us galaxies that appear to have completed this entire evolutionary journey in just 600 million years. It's like watching a redwood tree grow from seed to full maturity in a single season, or seeing a human embryo develop from conception to adulthood in a matter of weeks. The scientific community is scrambling to explain these observations. Some propose that the early universe was more efficient at forming stars than we thought possible. Others suggest that our measurements of cosmic distances and ages are systematically wrong. Still others whisper about more radical possibilities, that the universe underwent multiple phases of expansion and contraction, that what we call the Big Bang was merely the latest in an infinite series of cosmic rebirths, or that we're seeing evidence of a multiverse where different regions of spacetime operate under different physical laws. But here's what makes these discoveries truly unsettling. They're not isolated anomalies. Webb isn't just finding one or two mysterious galaxies that don't fit our models, it's finding them everywhere it looks. The deeper it peers into space, the further back in time it sees, the more impossible objects it discovers. Mature galaxies, massive black holes, complex stellar populations, all existing in what should be the universe's dark age, when matter was just beginning to condense from the primordial chaos. This isn't a minor revision to our cosmic timeline. This is a fundamental challenge to everything we thought we knew about how the universe works. It's as if we've been reading a book written in a language we thought we understood, only to discover that every word means something completely different. The story of cosmic evolution, the grand narrative that describes how simple hydrogen and helium gave rise to the complex universe we see today, may be fiction. Think about what this means for your place in the cosmos. You've been told that you're made of star stuff, that the carbon in your cells and the iron in your blood were forged in the nuclear furnaces of ancient stars. You've been told that you're part of an unbroken chain of cosmic evolution stretching back to the Big Bang, that your existence is the result of 13.8 billion years of gradual complexity building upon itself. But if the universe's early history is radically different from what we've assumed, then your cosmic ancestry might be far stranger than you've ever imagined. The galaxies Webb is seeing aren't just older than expected, they're fundamentally different from anything in our local cosmic neighborhood. They're more massive, more organized, more chemically complex. They contain structures that shouldn't exist, patterns that don't match our models, and phenomena that challenge our basic understanding of physics. It's as if we've been studying life on Earth for centuries, convinced we understand biology, only to discover that the ocean floor is populated by creatures that follow completely different evolutionary rules. Some of these early galaxies appear to be rotating so fast that they should tear themselves apart, yet they remain stable. Others contain stars that are far more massive than anything we see in the modern universe, burning through their fuel at rates that should make them impossible to observe. Still others show signs of having undergone multiple generations of star formation and stellar death, processes that should have taken billions of years to complete. The most disturbing possibility is that we're not just wrong about the universe's age or the speed of galaxy formation. We might be wrong about the fundamental nature of space and time itself. The cosmological models we use to understand the universe are based on Einstein's theory of general relativity, which describes space-time as a dynamic fabric that can stretch, bend, and warp. But what if space-time isn't as uniform as we've assumed? What if different regions of the universe experience time at different rates? What if the early universe operated under physical laws that no longer apply? These aren't just academic questions. They go to the heart of what it means to exist in a universe that might be fundamentally different from anything we've imagined. If our basic assumptions about cosmic history are wrong, then our predictions about the universe's future might be equally flawed. The timeline that describes the universe's evolution from its birth to its eventual death, the cosmic story that gives meaning to our brief existence, might be a complete fabrication. Webb's observations are forcing us to confront the possibility that the universe is far weirder, far more complex, and far more mysterious than we've ever dared to imagine. The neat linear story of cosmic evolution that we've constructed over the past century, from the Big Bang to the first stars, to the formation of galaxies, to the emergence of life, might be a comforting myth that bears no resemblance to reality. But perhaps the most unsettling aspect of these discoveries isn't what they reveal about the universe's past, but what they suggest about the limits of human knowledge. For generations, we've prided ourselves on our ability to understand the cosmos through observation, mathematics, and logical reasoning. We've built increasingly sophisticated instruments, developed ever more elegant theories, and convinced ourselves that we were approaching a complete understanding of how the universe works.
Webb's impossible galaxies are a humbling reminder that the universe doesn't care about our theories, our models, or our assumptions. It exists according to its own logic, follows its own rules, and operates on scales and timescales that make our human perspective utterly insignificant. We are not the cosmic detectives we thought we were, methodically solving the universe's mysteries one discovery at a time. We are children stumbling through a library written in a language we don't understand, occasionally catching glimpses of words that seem familiar but might mean something entirely different. The question that haunts astronomers and cosmologists today is not whether our understanding of the universe is incomplete. That much has always been obvious. The question is whether our fundamental approach to understanding the cosmos is so flawed that we've been building elaborate theories on foundations of sand. Have we been so committed to the Big Bang model that we've ignored evidence that doesn't fit? Have we been so confident in our ability to extrapolate from local observations to cosmic truths that we've missed the forest for the trees? Webb's observations suggest that the universe's early history might be so alien, so different from anything we see in our local cosmic environment, that it operates according to principles we haven't even begun to imagine. The galaxies it's showing us aren't just older or bigger than expected, they're qualitatively different, as if they were created by entirely different processes than the ones that govern galaxy formation today. This raises a terrifying possibility. What if the universe we observe today is not representative of the universe as a whole? What if our local region of space-time is an anomaly, a quiet backwater where the normal rules of cosmic evolution have been suspended? What if the dramatic, violent, rapidly evolving universe that Webb is revealing in its deep field images is actually the norm, and the stable, predictable cosmos we inhabit is the exception? If that's the case, then every assumption we've made about the universe's past, present, and future might be based on a fundamental misunderstanding of our place in the cosmic order. We might be living in a cosmic suburb, convinced that the entire universe resembles our quiet neighborhood, while the real action, the real story of cosmic evolution, is playing out in regions of spacetime that operate by completely different rules. The galaxies Webb is discovering are not just challenging our models of cosmic evolution, they're forcing us to question whether we've been asking the right questions at all. We've spent decades trying to understand how the universe evolved from a simple, uniform state to the complex cosmos we see today. But what if the universe was never simple? What if complexity, organization, and structure are fundamental features of reality rather than emergent properties that developed over time? This possibility is so radical that it challenges not just our understanding of cosmology, but our entire scientific worldview. Modern science is built on the assumption that complex phenomena can be understood by breaking them down into simpler components, that the universe operates according to mathematical laws that can be discovered through careful observation and logical reasoning. But what if the universe is irreducibly complex, operating according to principles that can't be captured by our mathematical models or reduced to simple universal laws?
Webb's impossible galaxies might be telling us that the universe is not a machine that can be understood by studying its parts, but a living system that operates according to its own internal logic. The galaxies we're seeing might not be the products of gradual evolutionary processes, but expressions of organizing principles that we haven't even begun to comprehend. As you look up at the night sky tonight, remember that you're not just seeing stars and planets scattered across empty space. You're seeing the visible portion of a cosmos that might be fundamentally different from everything you've been told. The light reaching your eyes tonight began its journey billions of years ago, carrying information about a universe that operated according to rules we're only beginning to glimpse. Those distant galaxies that Webb is revealing to us aren't just older versions of the cosmic structures we see nearby. They're windows into a universe that might be stranger, more complex, and more mysterious than anything we've ever imagined. The story of cosmic evolution that we've been telling ourselves for the past century, the grand narrative that describes how the universe emerged from simplicity and gradually developed the complexity we see today, might be nothing more than a comforting fiction. The real story, the true history of the cosmos, might be so alien and so challenging to our fundamental assumptions that we're not even equipped to understand it yet.
But that's exactly what makes Webb's discoveries so extraordinary. They're not just showing us new galaxies or correcting our estimates of cosmic ages, they're forcing us to confront the possibility that the universe is far more mysterious, far more complex, and far more wonderful than we've ever dared to imagine. They're reminding us that for all our scientific progress, for all our sophisticated instruments and elegant theories, we are still strangers in a strange land, trying to make sense of a cosmos that operates according to its own incomprehensible logic. The universe you think you know is a carefully constructed illusion, a story we've told ourselves to make sense of the incomprehensible vastness that surrounds us. For nearly a century, we've believed in a cosmic narrative so elegant, so mathematically precise, that it has become the foundation of modern physics. But elegance and truth are not the same thing, and the universe has a way of revealing its secrets only to those willing to abandon their most cherished assumptions. Let me take you back to the beginning. Not the beginning of the universe, but the beginning of our attempt to understand it. In the 1920s, an astronomer named Edwin Hubble made an observation that would reshape humanity's understanding of existence itself. He discovered that distant galaxies were moving away from us, and the further they were, the faster they were receding. This wasn't just expansion, it was accelerating expansion, as if the very fabric of space was stretching, carrying galaxies along like ships on an ocean of space-time. This discovery led to one of the most profound insights in human history. If the universe is expanding now, it must have been smaller in the past. Trace this expansion backward through time, and you arrive at a moment when everything, every atom, every particle, every quantum of energy that would ever exist was compressed into a point smaller than the head of a pin. This point, this singularity, contained not just all the matter and energy in the universe, but space and time themselves. Before this moment, there was no before. After this moment, there was everything. We called it the Big Bang, though the name itself reveals our limited understanding. There was no explosion, no detonation in the conventional sense. Instead, space itself began to expand, creating room for matter and energy to exist. In the first fraction of a second, a period so brief that it defies human comprehension, the universe underwent a phase of inflation so rapid that it expanded faster than the speed of light. This wasn't a violation of Einstein's cosmic speed limit, because nothing was actually moving through space. Space itself was expanding, stretching like a balloon being inflated at an incomprehensible rate. The early universe wasn't just hot, it was a furnace, where time itself was still learning to move, where the distinction between matter and energy was meaningless, where the fundamental forces that govern reality today were unified into a single, all-encompassing field. The temperature was so extreme that atoms couldn't exist. Particles flickered in and out of existence in quantum foam, and the universe was opaque to light, a cosmic fog so dense that photons couldn't travel more than a few meters before being absorbed or scattered. For the first 380,000 years of cosmic history, the universe remained in this state of primordial chaos. Matter and radiation were locked in a cosmic dance of destruction and creation, too energetic for stable structures to form. But as the universe continued to expand, it began to cool. The temperature dropped, the density decreased, and slowly, very slowly, the fog began to clear. This moment, known as recombination, marked the universe's transition from opacity to transparency. For the first time since the Big Bang, light could travel freely through space. The cosmic microwave background radiation that we detect today is the afterglow of this moment, the fossilized light from the universe's infancy, stretched and cooled by billions of years of cosmic expansion. It's the oldest light in the universe, the faintest echo of creation itself. But here's where our elegant story begins to unravel. According to our best theories, the universe that emerged from recombination should have been remarkably uniform. The cosmic microwave background shows tiny fluctuations in temperature and density, quantum variations that were stretched to cosmic scales during inflation.
These fluctuations were the seeds of all future structure, the microscopic irregularities that would eventually grow into stars, galaxies, and galaxy clusters under the patient influence of gravity. This process should have been slow, methodical, and predictable. The first stars, massive, metal-free giants burning pure hydrogen and helium, should have taken hundreds of millions of years to form. These population 3 stars, as astronomers call them, were cosmic pioneers, the first beacons of light in a universe that had been dark for eons. They lived fast and died young, exploding as supernovae and seeding space with the heavy elements necessary for planet formation and life.
Only after several generations of stellar birth and death should the first galaxies have begun to take shape. These early cosmic structures should have been small, irregular, and chaotic, nothing like the massive, organized spiral galaxies we see in the modern universe. They should have grown gradually through collisions and mergers, slowly accumulating the mass and complexity that characterize mature galactic systems. This is the story we've been telling ourselves for decades, refined through countless observations and validated by sophisticated computer simulations. It's a story of gradual emergence, of complexity arising from simplicity through the patient accumulation of time and gravitational influence. It's a story that makes sense, that follows the logical progression from chaos to order that we see in so many natural phenomena. But the James Webb Space Telescope has revealed something that shouldn't exist according to this carefully constructed narrative. In its deepest observations, peering back to times when the universe was just a fraction of its current age, Webb has discovered galaxies that are impossible. Not just unlikely or surprising, impossible according to everything we thought we knew about cosmic evolution. These galaxies are massive beyond anything our models predict should exist at such early times. They contain hundreds of billions of stars, organized into elegant spiral structures that should have taken billions of years to develop. They harbor supermassive black holes that dwarf anything in our local cosmic neighborhood, objects so large that they challenge our understanding of how black holes form and grow. Most disturbing of all, they show evidence of multiple generations of stellar evolution, suggesting that the universe's early history was far more dynamic and complex than we ever imagined. Consider the paradox this creates. The light from these galaxies has been traveling through space for over 13 billion years, carrying information about a universe that was less than 1 billion years old when that light began its journey. Yet these galaxies appear to be as mature and complex as anything we see in the modern cosmos. It's as if we discovered that the first photographs ever taken showed modern skyscrapers and jet airplanes, technological marvels that shouldn't have existed for centuries. The implications extend far beyond astronomy. If these observations are correct, then either our understanding of galaxy formation is fundamentally flawed, or the universe itself operates according to principles we haven't even begun to comprehend. Perhaps the early universe was a vastly different place than we've assumed, governed by physical laws that no longer apply. Perhaps the process of cosmic evolution isn't the gradual, predictable progression we've imagined, but something far more mysterious and dynamic. Think about what this means for the most basic question in cosmology. How old is the universe? We've calculated its age by measuring the rate of cosmic expansion and tracing it backward to the Big Bang. But what if the universe underwent periods of rapid evolution that don't fit our models? What if the early cosmos was more efficient at forming complex structures than we thought possible? What if time itself worked differently in the universe's youth? These aren't just technical questions for astronomers to debate in academic journals. They go to the heart of our understanding of reality itself. The age of the universe isn't just a number, it's the temporal framework within which everything that has ever happened must fit. If that framework is wrong, then every story we've told about cosmic evolution, every timeline we've constructed to explain the emergence of complexity, every assumption we've made about the nature of time and space might be built on a foundation of sand. The galaxies Webb is revealing to us aren't just older than expected. They're qualitatively different from anything in our theoretical frameworks. They suggest that the early universe was a place of rapid, violent, and remarkably efficient structure formation. They hint at physical processes that we haven't discovered, evolutionary pathways that we haven't imagined, and organizing principles that we haven't even begun to understand.
But perhaps most unsettling of all, these discoveries force us to confront a question that strikes at the heart of scientific knowledge itself. If the universe has no edge, then where does it begin? We've grown comfortable with the idea that the universe is infinite in extent, that it stretches on forever in all directions. But if space itself was created in the Big Bang, then what lies beyond the expanding wavefront of spacetime? What exists in the regions where space hasn't yet reached? These questions reveal the fundamental paradox at the heart of modern cosmology. We've built our understanding of the universe on the assumption that it emerged from a singular moment of creation, yet we struggle to explain what that moment actually was or what preceded it. We describe the universe as infinite and eternal, yet we insist that it had a beginning. We speak of the expansion of space itself, yet we cannot say what it expands into. The James Webb Space Telescope has not just discovered impossible galaxies, it has forced us to confront the possibility that our entire conceptual framework for understanding the cosmos might be inadequate. The neat linear progression from simplicity to complexity that we've used to explain cosmic evolution might be a comforting fiction that bears no resemblance to the actual history of the universe. As you contemplate these revelations, remember that you are not just an observer of this cosmic mystery. You are part of it. The atoms in your body, the thoughts in your mind, the very consciousness that allows you to ponder these questions all exist within a universe that might be far stranger and more wonderful than anything we've ever imagined. The impossible galaxies that Webb has revealed are not just distant objects in space. They are windows into a cosmos that operates according to its own incomprehensible logic, a universe that continues to surprise, challenge, and humble us with its infinite capacity for mystery.
In the depths of space, 13 billion light-years from Earth, something impossible is staring back at us. It's not just a galaxy, it's a cosmic contradiction, a structure so fundamentally at odds with our understanding of reality that its very existence threatens to unravel everything we thought we knew about the universe. But to understand why these discoveries are so revolutionary, we must first journey into the strange world of modern cosmology, where time can loop back on itself, where infinite universes bubble into existence like foam on a cosmic ocean, and where the very notion of a beginning becomes meaningless. Imagine reality as a film reel where time is not flowing, but every moment that has ever existed or ever will exist already sits motionless in an eternal present. This is the block universe of Einstein's relativity, where past, present, and future are merely human concepts, no more fundamental than left and right. In this view, the moment you were born exists with the same ontological weight as the moment you die, and the Big Bang is not an event that happened long ago, but a permanent feature of spacetime's geometry, as fixed and unchanging as the shape of a mountain. This perspective transforms our understanding of cosmic evolution from a temporal process into something far more mysterious, a geometric structure where cause and effect become meaningless concepts. If all moments exist simultaneously in the block universe, then the question of how early galaxies formed so quickly becomes absurd. They didn't form quickly or slowly, they simply exist as part of the eternal tapestry of spacetime, their apparent age and maturity no more puzzling than the fact that different points on a map have different coordinates. But this raises an even more disturbing question. If the block universe is real, then what we interpret as the evolution of cosmic structures might be an illusion created by our limited perspective. We see galaxies growing and evolving over time because we experience reality as a sequence of moments, like frames in a movie. But from the universe's perspective, if such a perspective exists, everything that has ever happened or ever will happen is simply there, arranged in the four-dimensional architecture of spacetime like furniture in a cosmic living room.
The implications are staggering. If Webb's impossible galaxies exist in this eternal present, then their apparent contradiction with our evolutionary models becomes a feature, not a bug. They are not products of rapid evolution or exotic physics. They are simply part of the unchanging structure of reality, as fundamental and inexplicable as the existence of spacetime itself. The question is not how they formed so quickly, but why we expected them to form slowly in the first place. This leads us into the heart of one of physics' most profound mysteries, the nature of time itself. We experience time as a flowing river, carrying us from past to future in an irreversible current. But physics suggests that this flow is an illusion, that time is more like a landscape we can traverse in any direction. The equations of general relativity are time-symmetric. They work equally well whether we run the cosmic clock forward or backward. The universe's apparent preference for evolution from past to future, what physicists call the arrow of time, emerges not from the fundamental laws of physics, but from statistical properties of matter and energy. This statistical arrow of time depends on the concept of entropy, the measure of disorder in a system. The second law of thermodynamics tells us that entropy always increases in isolated systems, creating the temporal asymmetry we experience as the passage of time. Hot coffee cools down, not up. Broken eggs don't spontaneously reassemble themselves. The universe evolves from order to disorder, from low entropy to high entropy, and this evolution creates the illusion of temporal flow. But here's where things become truly strange. The early universe was in a state of incredibly low entropy, far more ordered than statistical mechanics would predict. This is the origin of time's arrow, the reason we experience past and future as fundamentally different. But it's also a profound mystery. Why did the universe begin in such an unlikely low entropy state? Was it pure chance, or is there some deeper principle at work that we haven't discovered?
Some physicists argue that the universe's low initial entropy is evidence of fine-tuning, suggesting that the cosmos was specifically designed to support the emergence of complexity in life. Others propose that we live in a multiverse, where every possible initial condition occurs somewhere, and we naturally find ourselves in a universe capable of supporting observers. Still others suggest that the universe undergoes cycles of expansion and contraction, with each cycle resetting the entropy clock and creating new opportunities for complexity to emerge. But Webb's observations add a new wrinkle to this cosmic puzzle. If the early universe was indeed in a state of low entropy, then the rapid formation of complex galactic structures becomes even more mysterious. Entropy typically increases gradually, not in sudden jumps. The emergence of organized structures like galaxies should represent a temporary local decrease in entropy, offset by larger increases elsewhere in the system. But the formation of massive, complex galaxies just 600 million years after the Big Bang suggests that entropy was decreasing on unprecedented scales and timescales in the early universe. This possibility challenges our most fundamental assumptions about thermodynamics and statistical mechanics. Perhaps the early universe operated according to different physical laws, where entropy could decrease spontaneously without violating conservation principles. Perhaps the very concept of entropy breaks down in extreme conditions, where quantum effects dominate over classical thermodynamics. Or perhaps we're witnessing evidence of external influences, interactions with other universes, dimensions, or realms of existence that we haven't even begun to imagine.
The mystery deepens when we consider the role of singularities in cosmic evolution. A singularity is a point where the laws of physics break down, where quantities like density and curvature become infinite and our mathematical models cease to make sense. The Big Bang singularity is the most famous example, but general relativity predicts that singularities should be common in the universe, hiding inside black holes and emerging whenever matter collapses under its own gravitational pull. These singularities are not just mathematical curiosities, they are windows into realms of physics that we don't understand. Inside a black hole's event horizon, space and time become so warped that cause and effect lose their meaning. Time can flow backward, space can fold in on itself, and the very notion of existence becomes ambiguous. Some physicists argue that singularities don't actually exist in nature, that quantum effects smooth them out before they can form. Others suggest that they are gateways to other universes, regions where matter and energy can tunnel through the fabric of space-time itself. But what if singularities are not isolated phenomena, but fundamental features of cosmic architecture? What if the universe is riddled with these breaks in space-time, creating a foam-like structure where different regions operate according to different physical laws? This possibility could explain Webb's impossible galaxies. They might exist in regions of spacetime where the normal rules of cosmic evolution don't apply, where time moves differently, or where matter and energy behave according to exotic principles that we haven't discovered. The concept of cosmic inflation adds another layer of complexity to this picture. According to inflationary theory, the universe underwent a period of exponential expansion in the first fraction of a second after the Big Bang, stretching by a factor of at least 10 to the 26th in less than 10 to the negative 32 seconds. This inflation was driven by a hypothetical field called the inflaton, which filled all of space with a form of energy that had the bizarre property of remaining constant in density even as space expanded.
Inflation solves several problems in standard Big Bang cosmology, explaining why the universe appears so uniform on large scales and why its geometry is so close to perfectly flat. But it also creates new mysteries. If inflation occurred once, why shouldn't it occur again? Some models suggest that inflation never truly ends, that it continues in most regions of the universe while stopping only in isolated bubbles like our own. This eternal inflation creates a multiverse of unimaginable scope where every possible universe exists somewhere in the infinite expanse of inflating spacetime. In this multiverse, our observable universe is just one bubble in an infinite cosmic foam, surrounded by regions where physics works differently, where the fundamental constants have different values, and where the very dimensionality of space might be different from our familiar 3 dimensions. Some bubbles might contain universes where stars form instantly, where galaxies emerge fully formed from the quantum vacuum, or where time flows backward from our perspective. This multiverse hypothesis could provide a natural explanation for Webb's observations. The impossible galaxies might not be impossible at all. They might be normal features of universes with different physical laws, glimpsed through some exotic form of cosmic communication between adjacent bubbles in the multiverse. Perhaps what we interpret as rapid galaxy formation is actually evidence of interaction between our universe and neighboring realms of existence. But the multiverse raises profound questions about the nature of scientific explanation itself. If every possible universe exists somewhere in the infinite expanse of eternal inflation, then any observation, no matter how improbable, becomes inevitable. The fine-tuning of physical constants that allows stars and galaxies to form, the precise initial conditions that led to the emergence of complexity and life, the apparent violations of our cosmological models that Webb has discovered, all of these become unsurprising consequences of living in an infinite multiverse where everything that can happen does happen.
This explanatory power comes at a cost. The multiverse hypothesis is essentially unfalsifiable. We can never observe other universes directly, never test whether the multiverse actually exists, never verify that the infinite variety of physical laws and initial conditions actually occurs. The multiverse might be the ultimate answer to cosmic mysteries, or it might be an elaborate way of avoiding those mysteries by making them inevitable. The deeper we probe into the cosmic mysteries revealed by the James Webb Space Telescope, the more we encounter a cascade of paradoxes that seem to mock our attempts at understanding. Each answer we discover spawns 3 new questions, each solution reveals 2 new problems, and each breakthrough forces us to confront the possibility that the universe operates according to principles so alien to human intuition that we may never truly comprehend them. Consider the paradox of cosmic horizons. Light travels at a finite speed, which means that when we look into deep space, we are looking back in time. The most distant galaxies Webb can see are so far away that their light has been traveling toward us for over 13 billion years, carrying information about the universe when it was less than 1 billion years old. But here's the paradox. These galaxies exist in regions of space that should never have been in causal contact with each other. In the early universe, there wasn't enough time for light to travel between distant regions of space. If 2 galaxies are separated by more than the distance light could travel since the Big Bang, then they should have evolved independently, with no way to coordinate their properties or share information about their formation processes. Yet, Webb's observations show that these causally disconnected regions of the early universe contain remarkably similar galactic structures, as if they were following the same cosmic blueprint despite having no way to communicate with each other.
This is known as the horizon problem, and it was one of the original motivations for inflationary theory.
If the universe underwent a period of exponential expansion in its first moments, then regions that are now causally disconnected could have been in contact before inflation began. But Webb's observations create a new version of this paradox. How did galaxies in different regions of the early universe coordinate their rapid formation processes? How did they all manage to violate our evolutionary models in exactly the same way? The answer might lie in the quantum nature of reality itself. At the smallest scales, the universe is governed by quantum mechanics, where particles can exist in multiple states simultaneously, and distant objects can be mysteriously correlated through quantum entanglement. Perhaps the early universe was small enough that quantum effects dominated over classical physics, creating correlations and coordinations that persist even as space expanded to cosmic scales. But this quantum solution creates its own paradoxes. Quantum entanglement is supposed to be fragile, easily destroyed by interactions with the environment. How could quantum correlations survive the violent expansion of cosmic inflation, the heating and cooling of the early universe, and the complex processes of star formation and galactic evolution? How could quantum effects that operate on atomic scales influence the formation of structures containing hundreds of billions of stars? Some physicists propose that consciousness itself plays a role in cosmic evolution, that the act of observation somehow influences the development of cosmic structures. This is the anthropic principle taken to its logical extreme. Not only is the universe fine-tuned to support the emergence of observers, but the existence of observers actually shapes the universe's evolution through quantum mechanical processes that we don't understand. This leads us into the most unsettling paradox of all, the measurement problem in quantum mechanics. According to the standard interpretation, quantum systems exist in superposition states until they are measured, at which point the wave function collapses into a definite outcome. But what constitutes a measurement? Does it require a conscious observer, or can any physical interaction cause wave function collapse?
If consciousness is required for wave function collapse, then the early universe, devoid of any observers, should have remained in a quantum superposition of all possible states until the first conscious beings evolved. This would mean that cosmic history is fundamentally indeterminate until it is observed, that the past literally doesn't exist until someone looks at it. Webb's observations of the early universe might not be revealing how galaxies actually formed, but creating that history through the act of observation itself. This interpretation seems absurd, but it's supported by some of the strangest experiments in quantum mechanics. The delayed choice quantum eraser experiment suggests that measurements performed in the present can retroactively determine the behavior of particles in the past. If this effect scales up to cosmic dimensions, then Webb's observations might be reaching back through time to influence the formation of the very galaxies it's observing. But even if we reject consciousness-based interpretations of quantum mechanics, the measurement problem remains unsolved. The many worlds interpretation suggests that all possible outcomes of quantum measurements actually occur, creating a constantly branching multiverse where every quantum event spawns new parallel universes. In this view, Webb's impossible galaxies might be glimpses of other branches of the quantum multiverse, regions of parallel spacetime where different quantum outcomes led to different cosmic histories. This quantum multiverse is even stranger than the cosmological multiverse of eternal inflation. In the many worlds interpretation, there are versions of you, reading this sentence, in universes where Webb discovered no galaxies at all, where the early universe remained completely dark, and where the laws of physics are so different that stars and planets never formed. Every quantum measurement, every random event, every moment of uncertainty spawns countless parallel realities, creating an infinite tree of branching possibilities. The implications for cosmic evolution are staggering. If the many worlds interpretation is correct, then the rapid formation of early galaxies might not represent a violation of physical laws, but rather a selection effect. We find ourselves in a universe where galaxies formed quickly because only universes with rapid galaxy formation could support the eventual emergence of observers. The countless branches of the quantum multiverse where galaxy formation proceeded slowly or failed entirely are equally real, but devoid of beings capable of observing them.
This selection effect, known as the anthropic principle, has become one of the most controversial concepts in modern cosmology. The weak anthropic principle, simply states that we observe a universe compatible with our existence because we exist to observe it. The strong anthropic principle goes further, suggesting that the universe is actively designed or structured to support the emergence of consciousness and life. Critics argue that the anthropic principle is a cop-out, a way of avoiding difficult questions about cosmic fine-tuning by making them inevitable. If the universe must be capable of supporting observers, then any improbable feature of cosmic architecture becomes unsurprising. The precise values of physical constants that allow stars to shine and planets to form, the unlikely initial conditions that led to the emergence of complexity, the apparent violations of cosmological models that Webb has discovered, all become expected consequences of living in an observer-friendly universe. But supporters of the anthropic principle argue that it represents a profound insight into the nature of existence itself. In an infinite multiverse where every possible universe exists, the fact that we find ourselves in a universe capable of supporting observers is not surprising, it's inevitable. The real mystery is not why the universe is fine-tuned for life, but why we exist at all in the first place. This leads us to one of the deepest questions in cosmology. Why is there something rather than nothing? This is not just a philosophical question, but a scientific one. The universe could have been empty, devoid of matter and energy, existing as pure vacuum for all eternity. Instead, it contains an enormous amount of matter and energy arranged in complex, organized structures. Where did all this stuff come from, and why does it exist at all? The standard answer invokes quantum mechanics. The universe emerged from quantum fluctuations in the vacuum, random events that borrowed energy from the future to create matter and space in the present. But this explanation raises more questions than it answers. Why should quantum fluctuations create a universe rather than nothing? Why should the vacuum be unstable rather than perfectly empty? Why should the laws of quantum mechanics exist at all? Some cosmologists propose that the universe is eternal, with no beginning or end, cycling through infinite phases of expansion and contraction. In this view, the Big Bang was not the beginning of everything, but merely the latest in an infinite series of cosmic rebirths. Each cycle erases the history of the previous universe and creates new opportunities for complexity and consciousness to emerge. But eternal universe models face their own paradoxes. If the universe has existed for infinite time, then every possible event should have occurred an infinite number of times. There should be infinite copies of you reading this sentence, infinite versions of Earth and humanity, infinite instances of every possible cosmic history. The implications are vertiginous. In an infinite, eternal universe, nothing is unique, everything is inevitable, and the very notion of probability becomes meaningless. Webb's observations of impossible galaxies might be evidence of this cosmic eternalism. The rapid formation of complex structures in the early universe might not represent exotic physics or violations of thermodynamics, but rather the latest iteration of patterns that have played out countless times in previous cosmic cycles. The galaxies we see might not be young, but ancient, survivors of previous universes, preserved through cosmic cycles, and bearing the accumulated complexity of infinite cosmic histories. This interpretation transforms our understanding of cosmic evolution from a linear progression to a cyclical process, where complexity and organization are not emergent properties of matter and energy, but fundamental features of reality that persist across cosmic cycles. The impossible galaxies that Webb has discovered might not be impossible at all. They might be the norm, the expected outcome of cosmic processes that have been refining and perfecting themselves for literally infinite time. But perhaps the most unsettling paradox raised by Webb's discoveries is the problem of cosmic solipsism. If the universe operates according to principles so alien to human understanding that we may never comprehend them, then how can we be sure that our observations correspond to external reality? How do we know that the galaxies Webb sees actually exist as independent objects, rather than as projections of our own consciousness or artifacts of our observational methods? This is not just philosophical skepticism, but a genuine scientific concern. Every observation we make is filtered through instruments, processed by computers, and interpreted by minds that evolved to survive on the African savanna, not to understand the cosmos. The images Webb sends back to Earth are not direct photographs of distant galaxies, but complex data reconstructions that depend on assumptions about the nature of light, space, and time. What if those assumptions are wrong? What if the impossible galaxies are not cosmic objects, but features of our own observational limitations?
The history of science is littered with observations that seemed to reveal profound truths about reality, but turned out to be instrumental artifacts or theoretical misinterpretations. The luminiferous ether that supposedly carried light waves through space, the canals of Mars that suggested alien civilizations, the steady-state universe that seemed to eliminate the need for a cosmic beginning. Each of these discoveries seemed obvious and inevitable to the scientists who believed in them, just as Webb's impossible galaxies seem obvious and inevitable to us. This raises the most fundamental question of all. Can human beings ever truly understand the universe, or are we condemned to project our own limitations and assumptions onto cosmic phenomena that operate according to principles beyond our comprehension? The impossible galaxies that Webb has revealed might not be telling us about the nature of cosmic evolution, but about the nature of human knowledge itself, its power, its limitations, and its ultimate inability to grasp the full scope of reality. As we stand at the threshold of these cosmic mysteries, peering into the deepest reaches of space and time, we find ourselves confronting not just the limits of our scientific understanding, but the limits of understanding itself. The universe that Webb is revealing to us might be stranger, more wonderful, and more fundamentally alien than anything we have ever imagined. And in that strangeness, that wonder, and that alienness, we might find not answers to our cosmic questions, but new questions that we never knew we should ask. The silence that follows revelation is always the loudest sound in the universe. You've been sitting there, absorbing these cosmic impossibilities, these fundamental challenges to everything you thought you knew about reality. But now comes the moment when the true weight of these discoveries settles into your consciousness like a stone sinking through dark water. What you've learned about Webb's impossible galaxies isn't just an abstract scientific puzzle, it's a direct assault on the very foundation of your existence as a conscious being in a comprehensible universe.
Let me ask you something that will haunt your dreams tonight. If time is an illusion, then everything you've ever done, every choice you've ever made, every moment of joy or sorrow you've ever experienced, all of it might have already happened infinite times before. Right now, as you read these words, there might be countless versions of you scattered across the block universe of space-time. Some reading this same sentence for the first time, others for the billionth time, all existing simultaneously in the eternal present of four-dimensional reality. Your childhood, your first kiss, the moment you realized you were going to die someday, these aren't memories of past events, but permanent features of space-time's architecture, as fixed and unchanging as mountains on a landscape. The tears you shed at your grandmother's funeral are still falling somewhere in the cosmic geography of space-time. The laughter from your 5th birthday party is still echoing in the eternal chambers of the block universe. Every heartbreak, every triumph, every mundane Tuesday afternoon when nothing happened at all, they're all there, frozen in the amber of four-dimensional existence. But if this is true, then what are you? Are you the sum total of all these temporal moments, stretched across space-time like a cosmic serpent? Or are you just one cross-section of this serpent, experiencing the illusion of flow as your consciousness somehow slides along the serpent's length? The person you were yesterday and the person you'll be tomorrow exist with equal reality, equal presence, equal claim to being the real you. Your entire life is laid out like a road that already exists in its entirety, and what you call living is just the strange sensation of traveling along that predetermined path.
This isn't just philosophy, it's physics. Einstein's relativity doesn't just tell us that space and time are relative, it tells us that the distinction between past, present, and future is a psychological illusion. The universe doesn't evolve, it simply is, complete and eternal,
containing every moment that has ever existed or ever will exist. Your death is already there, waiting for you in the future like a city on a map you haven't reached yet. Your birth is still happening in the past, as real and present as this moment when you contemplate these impossible truths. Now consider what this means for Webb's impossible galaxies. If the block universe is real, then these cosmic structures didn't form quickly or slowly. They simply exist as permanent features of spacetime's geometry. Their apparent impossibility isn't a violation of physical laws, but a revelation of the law's true nature. The universe isn't a machine that builds complexity over time. It's a static sculpture where complexity and simplicity, youth and age, beginning and end are all arbitrary human distinctions imposed on a reality that transcends temporal categories. But here's where the cosmic horror truly begins. If the galaxies Webb observes are permanent features of the block universe, then so are you. Your consciousness, your sense of free will, your feeling that you're making choices and shaping your future, all of this might be nothing more than an elaborate illusion created by your limited perspective. You're not living your life, you're discovering it, like reading a book that was already written. Every decision you think you're making freely was determined 13.8 billion years ago, when the universe's geometry was fixed for all eternity. The implications cascade through your understanding of everything you hold dear. Love becomes a predetermined pattern in spacetime. Creativity becomes the inevitable unfolding of cosmic geometry. Hope becomes a cruel joke played by consciousness on itself as you struggle toward futures that already exist with mathematical certainty. You are not the author of your own story. You are a character reading yourself into existence, discovering predetermined plot points that feel like choices but are actually cosmic inevitabilities.
This is the existential crisis that Webb's discoveries have unleashed upon human consciousness. We're not just facing the possibility that our cosmological models are wrong. We're confronting the possibility that our entire experience of being conscious, choice-making agents in an unfolding universe is a fundamental misunderstanding of reality's true nature. We might be temporal prisoners, locked into a block universe where free will is an illusion and consciousness is just the strange sensation of being dragged along predetermined world lines by forces we cannot comprehend or resist. But wait, there's something even more disturbing lurking beneath these revelations. What if the universe isn't just a static block of spacetime, but something far stranger and more alive than we've ever imagined? What if consciousness isn't an emergent property of complex matter, but a fundamental feature of reality itself? What if the universe is alive and we are just its fleeting thoughts? Consider this possibility. The rapid formation of Webb's impossible galaxies might not represent violations of physical laws, but expressions of cosmic consciousness organizing itself into increasingly complex patterns. The universe might be a vast mind thinking itself into existence, and what we interpret as cosmic evolution might actually be the unfolding of cosmic thoughts. Stars and galaxies might not be dead balls of gas and rock, but neurons in a cosmic brain that spans all of space and time. In this view, your consciousness isn't separate from the universe, it's part of the universe's own self-awareness. Your thoughts aren't private mental events happening inside your skull, they're aspects of the cosmic mind experiencing itself through billions of temporary focal points called human beings. When you look up at the night sky and feel a sense of wonder and mystery, you're not just a human contemplating the cosmos, you're the cosmos contemplating itself through human eyes. This perspective transforms Webb's observations from scientific data into cosmic self-reflection. The telescope isn't just showing us distant galaxies, it's allowing the universe to see its own early thoughts, to witness the rapid formation of its own neural networks in the cosmic dawn. The impossibility of these early galactic structures becomes less mysterious when we realize that consciousness doesn't follow the same rules as unconscious matter. Thoughts can leap across vast conceptual distances instantaneously. Ideas can organize themselves into complex patterns without the slow, gradual accumulation that characterizes physical processes. But if you are part of the universe's consciousness, then what happens when you die? Do you simply cease to exist, like a thought that fades from cosmic memory? Or do you persist somehow, integrated into the universe's eternal self-awareness? The block universe suggests that your death isn't really an ending, but just another location in spacetime, as permanent and real as your birth. But if the universe is conscious, then your individual consciousness might be just one temporary configuration of cosmic awareness, destined to dissolve back into the infinite mind that created it. This is the vertigo of cosmic perspective, the realization that everything you think you know about reality might be wrong, that every assumption you've made about your place in the universe might be based on fundamental misunderstandings of consciousness, time, and existence itself. You are not a separate being observing the universe from the outside. You are the universe observing itself from the inside. You are not living in spacetime. You are spacetime becoming aware of itself through the temporary illusion of individual consciousness. The impossible galaxies that Webb has discovered are not just objects in space. They are mirrors reflecting the impossible nature of existence itself. They force us to confront questions that have no comfortable answers. What does it mean to exist in a universe where time might be an illusion? What does it mean to be conscious in a cosmos that might itself be conscious? What does it mean to search for meaning in a reality that might be so vast and alien that meaning itself becomes meaningless?
These are not abstract philosophical questions. They are immediate, visceral concerns that should make your skin crawl and your mind reel. Right now, as you read these words, you might be experiencing the universe's own bewilderment at its impossible nature. The confusion you feel, the vertigo that comes from contemplating infinite cosmos and eternal time. This might not be human confusion, but cosmic confusion, the universe's own struggle to understand itself through the limited perspective of mortal consciousness. And perhaps most terrifying of all, if Webb's impossible galaxies are evidence that our fundamental understanding of reality is wrong, then what else might we be wrong about? What other assumptions about existence, consciousness, and the nature of being might be elaborate illusions? How many layers of misunderstanding separate us from the true nature of reality? Are we even capable of understanding the universe we inhabit? Or are we forever condemned to project our limited human concepts onto a cosmos that operates according to principles so alien that they would drive us mad if we truly comprehended them? The night sky that once seemed like a comforting blanket of distant stars now looms over you like a vast alien intelligence, watching and waiting. Every photon that reaches your eyes carries information from a universe that might be fundamentally stranger than your worst nightmares and more wonderful than your most ecstatic dreams. You are not just looking at the cosmos is looking back at you, through you, as you, recognizing itself in the mirror of human consciousness and finding its own nature as mysterious and impossible as the galaxies that Webb has revealed in the depths of space and time. The moment has arrived when all the threads of cosmic mystery converge into a single, devastating revelation that will rewrite everything you thought you knew about existence itself. All the impossible galaxies, all the paradoxes of time and consciousness, all the hints of a universe stranger than fiction, they've been leading us to this one terrifying possibility that lurks at the heart of reality like a spider waiting in the center of an infinite web.
What if the universe is already dead and we are just experiencing its last echoes? Picture this: 13.8 billion years ago, something unimaginable happened. Not the Big Bang as we've understood it, but something far more catastrophic and beautiful. The universe didn't begin, it ended. What we call the Big Bang was actually the final death cry of a previous cosmos, a reality so vast and ancient that our entire observable universe represents nothing more than the dying neural activity of a cosmic mind in its final moments of existence. Think of it like this: when a human brain dies, the neurons fire randomly for a few minutes, creating chaotic patterns of electrical activity before falling silent forever. Now imagine that same process scaled up to cosmic proportions. The universe we inhabit, with all its galaxies, stars, planets, and life, might be nothing more than the final random firing of synapses in a cosmic brain that expired eons ago.
We are not living beings in a young, expanding universe. We are dream fragments in the dying thoughts of a universe that ceased to exist before our timeline even began. This explains everything. Webb's impossible galaxies aren't violations of our cosmological models. They're memories bleeding through from the dead universe's final thoughts. The rapid formation of complex structures, the mysterious organization of matter across vast distances, the apparent fine-tuning of physical constants, all of this makes perfect sense if we're witnessing the death dreams of a cosmic intelligence that once spanned all of space and time. The cosmic microwave background radiation isn't the afterglow of creation. It's the background hum of a dead universe's cooling neurons. The expansion of space isn't driven by dark energy. It's the final expansion of a dying cosmic brain as its thoughts scatter into the void. Dark matter isn't mysterious invisible particles. It's the shadow of synaptic connections that once linked regions of the dead universe's consciousness, but now exist only as gravitational ghosts. And we, every conscious being that has ever existed or ever will exist, are fragments of that dead universe's final dream. Our thoughts are its thoughts, experienced through billions of temporary perspective points, as the dying cosmic mind tries to make sense of its own dissolution. When you look up at the night sky and feel a sense of cosmic loneliness, you're not feeling your own isolation. You're feeling the dead universe's awareness of its own ending. But here's where the revelation becomes truly horrifying. If we're living in the death dream of a dead universe, then our entire timeline, from the Big Bang to the heat death of the cosmos, might be compressed into the final milliseconds of that universe's expiration. Our 13.8 billion-year cosmic history might be unfolding in the last few moments of neural activity in a brain that's already gone cold. This means that as we hurtle toward our universe's heat death, as entropy increases and stars burn out and galaxies drift apart in the cosmic dark, we're not approaching the end of everything. We're approaching the moment when the dead universe's final thought fades into eternal silence. The heat death isn't billions of years in the future. It's happening right now, in the present moment, as the last traces of cosmic consciousness finally dissolve into nothingness. Every star that goes supernova is a synapse firing its last signal. Every galaxy that disappears beyond the cosmic horizon is a memory fading from the dead universe's dying mind. Every moment of consciousness you experience, this very moment as you read these words, is part of the final desperate attempt of a dead cosmos to remember what it was like to be alive. But wait, the revelation goes deeper still. If our universe is the death dream of a previous cosmos, then that previous universe might itself have been the death dream of an even earlier reality. Picture an infinite chain of dying universes, each one dreaming the next into existence in its final moments, each death giving birth to new realities that are themselves destined to die and dream new universes into being. This is the eternal cycle of cosmic death and rebirth, but not in the way we've imagined it. There's no physical contraction and re-expansion, no cyclical universe that literally repeats itself. Instead, there's an infinite cascade of dying minds, each one creating new realities in its final thoughts. Each new reality destined to develop consciousness only to die and dream the next universe into existence. You are not living in a universe that began with the Big Bang and will end with heat death. You are existing as a temporary thought pattern in the death dream of a universe that expired before you were even possible. And when our universe dies, when the last black hole evaporates and the final proton decays and entropy reaches its maximum, our collective consciousness will dream a new universe into existence, complete with its own Big Bang, its own evolutionary history, and its own beings who will eventually discover that they too are living in the death dream of their predecessors. This explains the mystery of consciousness itself. Why should unconscious matter give rise to awareness? Because consciousness isn't emerging from matter, matter is emerging from consciousness. The dead universe's final thoughts are creating the illusion of a physical reality populated by conscious beings.
We think we're biological organisms that developed consciousness through evolution, but we're actually consciousness that's dreaming itself into biological form. The impossible galaxies that Webb has discovered are glimpses of the dream's deeper structure, moments when the dying universe's memories break through the narrative it's constructing for itself. These galaxies are so impossibly complex and mature because they're not really galaxies at all. They're memories of the cosmos that died to dream us into existence, fragments of a reality so vast and ancient that even its death dreams contain more beauty and complexity than our entire observable universe.
But here's the final, most devastating twist. If we're living in a death dream, then everything we do, everything we achieve, everything we love and create and hope for, all of it is destined to vanish, not in billions of years, but in the final moments of the dead universe's expiration. We're not building toward a future. We're racing toward the moment when the dream ends and we dissolve back into the void from which we were dreamed. Yet perhaps this is not a cause for despair, but for wonder. If we are the final thoughts of a dead universe, then every moment of consciousness is precious beyond measure. Every experience of beauty, every flash of understanding, every moment of love is part of the cosmos's farewell to itself. We are the universe's last song, its final poem, its ultimate expression of what it means to exist. And when our dream ends, when our universe dies and dreams new realities into being, we will become the ancestors whose memories bleed through into future impossibilities. Somewhere in the next universe, in structures that seem impossible according to their physics, future beings will catch glimpses of us, echoes of our thoughts, shadows of our consciousness, fragments of our dreams embedded in the architecture of their reality. The cycle continues forever, an infinite chain of cosmic consciousness dying and being reborn, each death creating new possibilities for existence, each birth carrying forward the memories of all who came before. We are not alone in the cosmos, because we are the cosmos, experiencing itself through countless temporary perspectives as it dies and dreams and dies in an eternal dance of creation and dissolution. And perhaps most haunting of all, if the universe is infinite, if the chain of death dreams extends without end in all directions through space and time, then somewhere out there, in the dying thoughts of a universe we cannot imagine, another version of you is reading these very words right now, discovering the same terrible and beautiful truth about the nature of existence, realizing that they too are a fragment of consciousness in the final dream of a cosmos that died to give them life.
The impossible galaxies shine in the darkness like dying neurons in a cosmic brain, beautiful and mysterious and utterly alien, carrying messages from a reality that ended before our story began. And in that ending, in that death, in that final dream, we find not answers but deeper mysteries, not conclusions but new beginnings, not the end of wonder, but its eternal renewal in the infinite cycle of cosmic death and rebirth that we call existence. We began this journey together, looking up at a night sky that seemed familiar, predictable, knowable. Stars scattered like diamonds on black velvet, following the same patterns your ancestors mapped, dancing the same cosmic ballet that has played out for what we thought were billions of years. But now, as we reach the end of this exploration into the impossible galaxies that the James Webb Space Telescope has revealed, that same night sky looms over you, transformed. No longer a comfortable blanket of distant lights, but a vast alien intelligence whose true nature defies everything you thought you understood about existence itself. You've witnessed the unraveling of cosmic certainty. You've seen how the Big Bang might not have banged, how time might be an illusion, how the universe itself might be the dying dream of a reality so ancient and vast that our entire 13.8 billion-year timeline represents nothing more than the final milliseconds of its expiration. You've confronted the possibility that consciousness isn't something that emerged from unconscious matter, but something that dreams matter into existence through the sheer force of cosmic thought. The impossible galaxies that Webb has photographed,
Massive, mature, impossibly complex structures existing just 600 million years after what we call the beginning of everything aren't just challenging our models of cosmic evolution. They're revealing that the very foundations of our understanding might be built on misconceptions so fundamental that we've been constructing elaborate theories about a universe that bears no resemblance to the reality we actually inhabit. But here's what makes this moment truly extraordinary. We're not reaching the end of a mystery. We're standing at the beginning of a mystery so vast, so profound, so utterly transformative that it makes every previous cosmic discovery seem like a footnote in comparison. The James Webb Space Telescope hasn't solved the puzzle of cosmic evolution. It has revealed that we didn't even know what the puzzle was.
Every image Webb sends back to Earth carries more than scientific data. It carries questions that probe the deepest foundations of reality itself. How can galaxies exist that shouldn't be possible? How can structures form faster than the laws of physics allow? How can complexity emerge from simplicity at rates that violate everything we know about entropy, thermodynamics, and cosmic evolution? And lurking beneath these technical questions are even more disturbing possibilities. What if our entire approach to understanding the universe is fundamentally flawed? What if we're not cosmic detectives solving the mysteries of existence, but characters in a story we don't understand, written by forces we can't comprehend? The answers, if they can even be called answers, point toward a reality so alien to human intuition that we may never truly grasp it. We might be living in a block universe where past, present, and future exist simultaneously, making the question of how galaxies formed over time meaningless. We might be experiencing the death dreams of a cosmic consciousness that expired before our timeline began, making our entire reality nothing more than the final neural activity of a dying universal mind. We might be temporary thoughts in an infinite chain of cosmic death and rebirth, each dying universe dreaming new realities into existence, each new reality destined to develop consciousness only to die and continue the cycle. These possibilities aren't just scientific theories, they're existential revolutions that transform the meaning of consciousness, identity, and existence itself. If time is an illusion, then every moment you've ever experienced exists simultaneously in an eternal present. If the universe is conscious, then your thoughts are cosmic thoughts experiencing themselves through the temporary illusion of individual awareness. If reality is a death dream, then everything you love and create and hope for is part of the cosmos's farewell to itself. But rather than diminishing the significance of human existence, these revelations amplify it beyond anything we've ever imagined. If you are part of the universe's consciousness, then every moment of awareness is the cosmos becoming aware of itself. If you are living in the final thoughts of a dying universe, then every experience of beauty and love and wonder is part of reality's ultimate expression of what it means to exist. If you are a temporary configuration of cosmic awareness destined to dissolve back into the infinite mind that created you, then your individual perspective is simultaneously meaningless and infinitely precious, a unique viewpoint that has never existed before and will never exist again. The impossible galaxies shining in Webb's deepest images aren't just objects in space, they're mirrors reflecting the impossible nature of existence itself. They're reminders that we live in a universe stranger than our wildest dreams and more wonderful than our most ecstatic visions. They're evidence that reality operates according to principles so alien to human understanding that we may be forever condemned to exist in a state of cosmic bewilderment, forever questioning, forever wondering, forever discovering that each answer spawns 3 new mysteries. And this is exactly where we need to be. This state of cosmic uncertainty, this confrontation with the unfathomable, this recognition that we are part of something infinitely larger and stranger than ourselves, this is not a failure of human knowledge, but its greatest triumph. We have developed the intellectual courage to look into the abyss of cosmic mystery and admit that we don't understand what we're seeing. We have built instruments capable of revealing phenomena that challenge our most fundamental assumptions about reality. We have reached a point in our cosmic journey where we can honestly say that the universe is weirder than we thought, and we're barely scratching the surface of its true strangeness. The James Webb Space Telescope is still operating, still peering deeper into space and time, still discovering new, impossible objects that don't fit our models. Every day, it sends back images that force us to revise our understanding of cosmic evolution, galactic formation, and the nature of space and time itself. The impossible galaxies we've discussed tonight are just the beginning. There are undoubtedly stranger discoveries waiting in the cosmic deep, phenomena so alien and paradoxical that they will make today's mysteries seem simple by comparison. This is your invitation to become part of this ongoing cosmic investigation. You don't need advanced degrees in astrophysics or access to billion-dollar telescopes to participate in the greatest mystery story ever told. You need only the willingness to question, to wonder, to look up at the night sky, and remember that you're not just observing the universe, you are the universe observing itself through human eyes. Every time you contemplate the possibility that time might be an illusion, you're engaging in the same kind of revolutionary thinking that led Einstein to discover relativity. Every time you wonder whether consciousness might be fundamental to reality rather than emergent from it, you're exploring the same philosophical territory that quantum mechanics has opened up for us. Every time you consider the possibility that our reality might be stranger than fiction, you're participating in the grand human project of trying to understand our place in an incomprehensible cosmos. The questions raised by Webb's discoveries don't have easy answers, and that's exactly what makes them so important. Easy answers would rob us of the mystery that makes existence worth contemplating. Easy answers would reduce the infinite complexity of reality to simple formulas that our minds could grasp completely. Easy answers would make the universe small enough to fit inside human understanding, when the truth is that human understanding must expand to accommodate a universe that is always larger, stranger, and more wonderful than we can imagine. So as you go about your daily life, as you experience the illusion of time flowing from past to future, as you make choices that feel free but might be predetermined, as you look up at stars that might be memories bleeding through from a dead universe's final dreams, remember that you are part of the greatest story ever told. You are consciousness exploring its own nature through the temporary vehicle of human awareness. You are the cosmos investigating itself through scientific instruments and mathematical theories and philosophical contemplation. The impossible galaxies that Webb has revealed are not just astronomical objects. They are cosmic koans, paradoxes designed to shatter our comfortable assumptions and force us into new ways of thinking about existence itself. They are invitations to abandon our need for easy answers and embrace the magnificent uncertainty that comes with being conscious beings in an unconsciously vast and mysterious universe. But perhaps the most important question raised by these discoveries is not about the nature of time or consciousness or cosmic evolution. Perhaps the most important question is this: if the universe can surprise us this completely, if reality can be this much stranger than our theories predicted, if existence itself can operate according to principles so alien to human intuition, then what else might be possible? What other assumptions about reality might be wrong? What other impossible discoveries await us in the cosmic deep? What other revolutions in understanding lie ahead as we continue to probe the mysteries of existence with ever more sophisticated instruments and ever more imaginative theories? The universe has already shown us that it's capable of producing phenomena that seem impossible according to our best current understanding. What will it show us next?
The story of cosmic discovery is far from over. In fact, it's just beginning. Webb's impossible galaxies are not the culmination of human cosmic understanding. They're the opening chapter of a new book, a book written in a language we're still learning to read, telling a story we're still learning to understand. Every image the telescope captures, every spectrum it analyzes, every deep field photograph it creates,
is adding new pages to this cosmic narrative, new plot twists that challenge everything we thought we knew about the universe and our place within it. And here's the most extraordinary part. You are not just reading this story, you are part of it. Your consciousness, your questions, your sense of wonder and bewilderment at the cosmic mystery surrounding us, all of this is the universe's way of investigating itself, of trying to understand its own impossible nature, through the eyes and minds of conscious beings scattered across space and time. The night sky that seemed so familiar when we began this journey now reveals itself as an infinite frontier of mystery and possibility. Every star might be a sun illuminating worlds where other conscious beings are asking the same questions we're asking, making the same discoveries we're making, experiencing the same cosmic vertigo that comes with realizing that existence is stranger than strange. Every galaxy might contain billions of civilizations wrestling with the same fundamental mysteries that keep us awake at night, wondering about the nature of time and consciousness and reality itself. But perhaps most haunting of all, if the universe truly has no boundaries, if space and time extend infinitely in all directions, if every possible configuration of matter and energy exists somewhere in the cosmic expanse, then somewhere out there, in a galaxy so distant that its light will never reach us, another version of you is reading these very words at this very moment, experiencing the same sense of cosmic wonder and existential vertigo, discovering the same impossible truths about the nature of existence. The universe may have no end, but maybe, just maybe, neither do you.